The Native Fish Conservation Program in Yellowstone preserves and restores native fish to maintain their important role in the ecology of the park and also to provide for unique sport fishing opportunities. So today I'd like to describe to you the work we're doing in Yellowstone on Yellowstone Lake, on conservation of fish in streams including westslope cutthroat trout and Arctic grayling, Yellowstone cutthroat trout restoration in the northern range, and some discussions about angling in Yellowstone and prevention of aquatic invasive species. So on Yellowstone Lake, we've had a major effort to restore the ecosystem by suppressing non-native invasive lake trout and recovering the native cutthroat trout population there. Yellowstone cutthroat trout are the sole trout of Yellowstone Lake and evolved here after glacial recession with only one other fish species, a small minnow, long-nosed dace. So for thousands of years, the cutthroat, being the only trout in Yellowstone Lake, were an important food source for many avian and terrestrial species in this ecosystem. Yellowstone Lake is considered the largest high elevation lake in North America. It has a depth of nearly 400 feet. The average depth is about 140 feet, and it has a surface area of 136 square miles. The problem occurred when historical introductions of non-native trout came to Yellowstone in the early 1900s. One significant introduction of non-native fish occurred in 1890 when lake trout, which are native to the Great Lakes and portions of Canada, were introduced to Lewis and Shoshone lakes in the upper Snake River. Lake trout were then discovered in Yellowstone Lake in 1994 for the first time and thought to have been illegally introduced potentially by anglers who just wanted lake trout in the lake for fishing. This was a problem because lake trout are highly predaceous species. In other lakes of the western United States where they had been introduced, they had decimated the native fishery of those large lakes. And so when lake trout were first discovered in Yellowstone Lake, it was very alarming for the Park Service. So why are lake trout a problem? They're a predatory species. They live only within Yellowstone Lake, and they do not use spawning streams the way cutthroat do in the spring to spawn. They are deep dwelling in the lake, and that means they're not accessible then to avian and other terrestrial consumers because they're deep within the lake and can't be accessed. They're extremely long-lived by comparison to cutthroat trout, and they produce thousands of eggs in a given year. So the impact of the lake trout on our native cutthroat has been pretty significant. So lake trout, as shown on this graph by the red line, increased dramatically in abundance and biomass from the late 1990s through the late 2000s. At the same time, we witnessed dramatic declines in our native Yellowstone cutthroat trout in spawning streams and within the lake itself. The loss of the cutthroat trout affected several important consumer species in the ecosystem that depended on them for a food resource. This included black and grizzly bears, as shown in the top graph. The cutthroat trout are the solid brown line in the top graph, and the dashed line is the use of spawning streams by grizzly bears. And the grizzly bear use of spawning streams mirrored the decline of the cutthroat trout during that time, but in recent years has been increasing with the increases in cutthroat trout that we're starting to see within the lake. The middle graph are the osprey, which only eat fish, and osprey nests declined from about 60 nests on average in the year 2000 to now where we only see about one osprey nest per year around Yellowstone Lake. The bottom graph are the abundance of eagles' nests around Yellowstone Lake. The solid line are the numbers of nests. The dashed lines are the success of those nests, which reached a low around 2009 and 2010. Eagles rebounded though because they were able to use other food resources in the lake area, including scavenging on carcasses, and they've also switched to alternative prey, including trumpeter swan cygnets and common loons. So since 1995, after the lake trout were discovered in Yellowstone Lake, we've been conducting a gill netting program to suppress the population and allow the cutthroat trout to recover. Each year, a large fleet of gill netting vessels gill nets lake trout from late May until mid-October. So we have large boats and crews working on Yellowstone Lake every year. These crews are using monofilament gill nets to net for lake trout. These gill nets are set beginning in late May when the ice comes off the lake until mid-October when winter begins to set in on Yellowstone Lake. The nets are lifted from the lake with a hydraulic net lifter shown here, and then the fish are sorted from the net, picked from the nets by these crews. They work all year, all season long. The crew members come from pretty much all over the United States and work with us on Yellowstone Lake. We also do telemetry of lake trout, as shown here, where we'll tag the fish with acoustic tags, these live fish that were netted, and then they're released back to Yellowstone Lake, where we can then track them and they can take us essentially to other congregations of fish. The dead lake trout are dumped back into Yellowstone Lake in deep areas of Yellowstone Lake. Each year we catch about 300,000 or more lake trout that are then returned to Yellowstone Lake to maintain the nutrients within the system.
No more fin left, they got eaten away. So that's the first thing to decompose seems to be the fins on these fish.
So we've been doing research to better understand the fate of the carcasses that end up dumped to the bottom of Yellowstone Lake, to better understand any impacts when we might be having on the nutrients within the lake. Over time, the gill netting program progression has looked like this from the 1990s in the top left through 2019. The red color indicates the concentrations of gill nets set across Yellowstone Lake over time, and the expansion in lake-wide, and then in the intensity of the netting by the darker shades. In a given year, our nets now look like this, where they're set across Yellowstone Lake by these various boats that work out on the lake all summer long. The nets are set in a serpentine pattern shown by the zigzag patterns of these lines. These are all net sets on Yellowstone Lake. And they're set in this way to improve the capture of the lake trout, which tend to follow the nets when they encounter them. So beginning in about 2012 to 13, we really increased our effort, which is shown here on the y-axis, in 100 meters of net per night, to a point where we were able to curtail further lake trout population growth. And then the amount of net that we set now annually is about 6,000 miles of gill net that is actually put in the lake and then retrieved to kill lake trout. So when we were able to get enough effort out in the lake beginning about 2012 is when we began to put the lake trout population into significant decline. The black line here is the decline of adult age 6+ lake trout, which we've reduced by more than 80% since 2012. The white line are the middle-aged lake trout, age 3 to 5, which we've also caused to decline in recent years. What we still catch, though, are an abundance of age 2, very young recruiting lake trout, which has been variable over years, but still fairly strong, and they represent a high proportion of our annual catch. We're working on methods to suppress lake trout in an integrated pest management approach where we can attack multiple life stages of the fish. We are working to suppress lake trout when they spawn in the fall by killing the embryos, the eggs that they release on their spawning areas in mid to late September. We know of about 14 spawning areas that the lake trout use within the lake, which are shown by the cross-hatched polygons here. We also have suspected areas across the lake, which are in the gray shaded areas, but we haven't found eggs in those locations yet. We've located these areas by telemetry of the tagged lake trout in the fall by tracking them to their spawning sites. We're hopeful that suppression of the embryos on spawning sites can be an efficient way to suppress the population, because the total area of the 14 verified spawning sites we know of is only 0.03% of the entire lake surface area. So if we're able to suppress lake trout on these small lake areas, it could be highly beneficial then to try and net them as they're free swimming throughout the lake, throughout the rest of the year. We began by just dumping the dead lake trout carcasses on top of these spawning sites to see if we could kill the eggs, and they do. The decomposition of the rotting lake trout carcasses quite quickly removes all the dissolved oxygen from the water, and then quickly kills the embryos on these sites. We've also ground the lake trout carcasses, so this is all ground lake trout material here drifting down to the bottom of the lake. And it turns out it doesn't take that high of coverage of lake trout carcass material to cause pretty high mortality of the embryos on these spawning sites. So we've been conducting treatments of spawning areas in Yellowstone Lake with these organic pellets made of soy and wheat gluten. On the upper left is a cedar spreader, which is completely full of the organic pellets. The cedar spreader is slung below a heavy helicopter, and the helicopter is then used to apply the pellets to the spawning sites out on Yellowstone Lake. The center image is the organic pellets after treatment, immediately after treatment, and the coverage that we've been able to achieve to cause the organic decomposition and the mortality of the lake trout embryos on that site. So just within part of the day, we can use a heavy helicopter to apply the pellets to a primary spawning site in the west dome of Yellowstone Lake called Carrington Island. And the cedar spreader is shown here below the helicopter. The helicopter prop draft actually forces the pellets down to the surface of the lake and towards the bottom, which is highly beneficial to keep the material on the spawning sites rather than having it drift. So Carrington Island was completely treated with organic pellets both in October of 2019 and 2020. Assessments of lake trout fry in the spring of 2020 indicated that nearly all recruitment was eliminated from Carrington Island by our treatments with organic pellets. We believe that this method has the potential for curtailing lake trout recruitment from additional sites across Yellowstone Lake in the future. What about our cutthroat trout, and how are they recovering in the Yellowstone Lake ecosystem? Up on the top right, this is the abundance of juvenile cutthroat trout from 2011 through 2020, and they are steadily increasing over time in the Yellowstone Lake ecosystem, which we're very happy to see. Our large cutthroat trout, shown here on the upper left, the white boxes here, which are increasing from the 1980s through this past decade, is the individual weights of the large cutthroat trout. Now when you catch an 18 to 20 inch cutthroat trout in Yellowstone Lake, it weighs on average twice as much as an 18 to 20 inch cutthroat trout did prior to the lake trout invasion. So although the abundance of cutthroat trout overall isn't where we want it to be to meet our recovery goals, the quality of the angling is actually quite high because of the quality and the size of the fish that you catch. These fish migrate long distances into the backcountry of Yellowstone and in the Bridger-Teton wilderness of Wyoming as they migrate up the upper Yellowstone River to spawn. We have made trips into the backcountry to find these fish during their spawning period.
Fish, 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 fish. Wow. You got him, got him. Boy just wants to run upstream.
So this is in early July of 2019.
Boy, she's a little, oh, rough life. You escaped lake trout for 5 years to be harassed up here in Yellowstone Meadows. I'm gonna grab a.
So the cutthroat trout migrate long distances back into the thoroughfare region of the upper Yellowstone River.
Working hard, trying to make babies.
Atlantic Creek is where they are here.
Come on, Mama, you got some fight.
The bottom line is that the lake trout suppression program on Yellowstone Lake has resulted in the return of large migratory cutthroat trout to the upper Yellowstone River backcountry. There are other emerging threats to Yellowstone Lake. We recently discovered a cisco, not native anywhere in the West, during routine gill netting operations in August of 2019. The fish we caught was an age 3 female, and otolith microchemistry analysis indicated that this fish was actually born in Yellowstone Lake, meaning that it has parents and probably thousands of siblings within the lake. Cisco are preferred prey of non-native lake trout, and they are also would be a direct competitor to our native cutthroat trout for the same food resources. We are monitoring for cisco using netting, and also we're examining the stomachs of our netted lake trout to see if we can find more of these fish within the lake. There's no doubt that if the cisco population expands and becomes very abundant in the lake, it'll be at the cost of our native cutthroat trout because they rely on the same food resources. We've also recently found microplastics within Yellowstone Lake. Microplastics are small plastic particles less than 5 millimeters in size, usually filamentous. And we found microplastics within the lake water column. We also found microplastics within 3 trophic levels within the lake, indicating that microplastics are being consumed by the organisms within the lake. These included amphipods, which are small crustacean species that are heavily preyed upon by cutthroat trout and lake trout. We found them within cutthroat trout stomachs, and we found them also within lake trout stomachs. The impacts of microplastics on the food web of Yellowstone Lake are unknown, but we intend to conduct further research to better understand this problem. In summary for Yellowstone Lake, since 2012, the lake trout have been harvested at a rate greater than anywhere else on Earth. More than 3.65 million have been killed since 1995. Adult lake trout have been reduced by more than 80%. However, the recruitment of age 2 fish remains strong. Treatments of spawning sites may help to reduce recruitment, and cutthroat trout are showing strong signs of recovery, but other components of the food web have yet to respond. Outside of Yellowstone Lake, we've been completing several projects to restore not only Yellowstone cutthroat trout in the northern range as shown here, but also other important native fish species, west slope cutthroat trout and Arctic grayling, native to the Gallatin and Madison drainages in the western region of the park. Threats to these populations are also non-native fish. Hybridizing rainbow trout especially have caused major losses of native cutthroat trout across the park. Competition by brown trout and brook trout are also problems in these areas. Our approach is to create headwater refuges for native fish in pristine areas where they can persist long term. We create headwater refuges for native fish by using either an existing natural features such as the waterfall, Little Gibbon Falls on the Upper Gibbon River. In some cases, we'll modify existing waterfalls such as on Grayling Creek in the lower right or Sotobu Creek Icebox Canyon in the upper center. Or in other places, we'll create new structures out of concrete, such as in the SLOUGH Creek Canyon in the lower left, or the East Fork Specimen Creek barrier, which is a log constructed barrier in the upper left. The only way to completely remove the non-native fish from these restoration areas is to use an approved pesticide called rotenone. Rotenone treatments occur to remove all hybridized and non-native fish from these regions above these barriers to make the habitat suitable then for the reintroduction of the native species. We reintroduce native fish typically as gametes using remote site incubators, which are these essentially 5-gallon buckets here where the embryos are placed in arrays as shown here on Grayling Creek, and then left where they can hatch and emerge into the stream and hopefully imprint on that stream to return later as adults to spawn. We have done several reintroductions also though as juveniles or adult fish using helicopters or other means to get them restocked into some park waters. So these are large in-stream remote site incubators used for grayling, Arctic grayling up in the South Fork of Grayling Creek. Essentially, you create flow through these incubators so when the eggs hatch, they can emerge with that flow back out into the stream. And here these are Arctic grayling fry that have emerged from the remote site incubators in the South Fork of Grayling Creek. These projects to restore Arctic grayling, West Slope cutthroat trout, or Yellowstone cutthroat trout to these backcountry areas are large, require interagency collaboration to get done. Here in Grayling Creek and in the Upper Gibbon River, for example, we have staff from the Park Service, Montana Fish, Wildlife and Parks, the U.S. Fish and Wildlife Service, Turner Enterprises, the Gallatin National Forest, and Yellowstone Forever. We also work very closely with Wyoming Game and Fish Department on these projects. So our major projects in recent years have been to restore West Slope cutthroat trout to the East Fork Specimen Creek, Grayling and West Slope cutthroat to Grayling Creek, and Grayling and West Slope cutthroat to the Upper Gibbon River above the Virginia Cascades. We've also learned about the dispersal of some of our native fish downstream, both Grayling and West Slope cutthroat trout. As shown here is this example of a grayling caught in the grayling arm of the Hebgen Reservoir, downstream of Grayling Creek. Our Yellowstone cutthroat trout conservation efforts are mostly focused in the northern range of the park, especially in the LAMAR River drainage. We're working hard to preserve our native large river, LAMAR River cutthroat. Overall, we've restored 80 miles of streams to native fish in recent years, and over 280 lake acres, most of the lake acreage being Grebe and Wolf lakes in the upper Gibbon River. We've stocked 2,000 Yellowstone cutthroat trout gametes, over 95,000 West Slope cutthroat trout gametes, and 150,000 Grayling. Similarly, we've stocked thousands of cutthroat trout and Grayling as fish. In the future, we intend to focus our restoration efforts on the Buffalo Fork of Slough Creek. In the northern range, we've been conducting selective removals of rainbow trout and hybrid trout by electrofishing, but also by collaboration with fly fishing volunteers and interested anglers in the conservation of cutthroat in this region. The LAMAR River and Slough Creek are important cutthroat trout strongholds that we're working hard to maintain. The electrofishing removals of rainbow are preserving the cutthroat trout. A barrier on lower Slough Creek is preventing future rainbow invasion of the upper Slough Creek meadows. But wranglers also play a big role in preserving our cutthroat trout, because each trout in the LAMAR is caught and released an average of 5 times per year. That means that anglers can effectively remove rainbow trout and hybrids from this system. We've conducted trout tracking, telemetry of trout throughout the LAMAR, especially during spring spawning period, when all the hybrids and rainbow trout congregate down in the lower LAMAR River, lower Slough Creek, and lower Buffalo Creek area of the watershed. We've learned that Buffalo Creek is a primary source of rainbow trout hybridization to the LAMAR River system itself. So in the map here is genetics integrity of the cutthroat trout, and you can see the red is the more highly hybridized or genetically pure rainbow trout, which origin is in the Buffalo Creek. So Buffalo Creek is a large tributary of Slough Creek. It's a main source of rainbow trout in Slough Creek and the LAMAR River, and it's recommended for a rotenone piscicide treatment starting actually this summer in 2021. And this is a collaborative project between Montana Fish, Wildlife, and Parks, the U.S. Forest Service, and the National Park Service. The Buffalo Creek project is a priority for preservation of the LAMAR River cutthroat trout. Finally, a few notes about angling overall in Yellowstone. Where typically over 40,000 anglers visit the park each year. In terms of where do people go, what waters are used mostly, you can see in this pie chart, Yellowstone Lake is used about 20% by 20% of the anglers that come to the park. It's the highest use of any park water. But the Madison River, the Firehole River are also highly used, along with the LAMAR River, Slough Creek, Yellowstone River, the Gibbon River, and Soda Butte Creek. 19% of all angler use then occurs at other smaller waters across the entire park. Native species are a majority of the catch by visiting anglers to the park, including cutthroat trout, which recently 62% of anglers were catching cutthroat trout. Other highly caught species are rainbow trout at 11%, brown trout at 11%, brook at 6%, and then whitefish and grayling. The data that I just presented to you was acquired by the volunteer angler report cards that were sent to us this past year. For a large number of the park's waters where we're not able to get to as biologists, the angler report card information is really the only fish population data that we have. And so these cards are very valuable to us as biologists in managing the park-wide waters. We are also implementing an online volunteer angler report card system beginning in 2021. And this system should be up and running by the fishing season Memorial Weekend. And you'll be able to log on to a website, provide your Yellowstone National Park fishing permit number, and enter your information about your catch for that trip. And you'll be able to enter information for multiple trips throughout the entire fishing season in 2021 and into the future. This will be highly valuable to us also as biologists in the park, because all the information now will come in electronically and not have to be hand entered from the old school report cards that we would get in the mail. Lastly, I'd like to talk about our aquatic invasive species prevention program in Yellowstone. Aquatic invasive species are a continuous threat to Yellowstone's waters, and they will be far into the future. We have existing species in the park, of course, lake trout that we just talked about today, whirling disease, New Zealand mud snails. We have existing species in the park that we need to keep from moving from one water body to another by keeping gear clean as you fish in one area and then move to another. You don't want to be moving these species with you. There are also multitudes of threatening aquatic invasive species advancing westward across the United States and threatening Yellowstone. These would include, of course, dry-sinted mussels, zebra mussels, and quagga mussels, which devastate ecosystems and would be a significant problem for Yellowstone Lake or anywhere in the park if they were introduced. Other species can be equally invasive and a problem though. For example, curly-leaf pondweed, as shown here, completely chokes out small bays and marina areas if it's introduced, and is very difficult to remove once it gets into the system. Species like Asian carp, which are raising havoc in the upper Mississippi River system, probably could easily find a place to live in Yellowstone if they were introduced here, as can be many other non-native species if they're brought here. The only way to maintain Yellowstone is to make sure these species don't get introduced in the first place, because once they're introduced, they're almost impossible to then eliminate. This is the origin of watercraft coming to Montana in a given year. And so it just highlights the importance of keeping clean watercraft, because they're coming from basically every state in the country, including Hawaii. And they can be carrying species from all these locations right here to the Yellowstone Park. So watercraft inspections are mandatory prior to launching in Yellowstone National Park. Watercraft inspections are provided by our resource management staff in Yellowstone. And when you arrive and purchase a permit to go boating in Yellowstone Park, you'll then be asked for an inspection and put through an inspection process. Each year, about 4,000 watercraft or so are inspected in the park, of which about 900 or so are actually motorized vessels. If a vessel arrives in the park and is dirty and may contain aquatic invasive species, it will undergo a full decontamination by hot, high-pressure water. Funding for the projects that I've described today are National Park Service dollars, including funding that comes in from the sale of fishing permits. But also, a large part of the program is supported by our fundraising partner, Yellowstone Forever. Just want to thank you for listening to the presentation today. Everything that I presented is done by a large group of individuals that work in Yellowstone each year. These folks come from all across the country and are very committed to Yellowstone's aquatic resources. And so as a group, we want to thank you for all of your support.